All right, let's do the problems from the 5.6 book assignment. So I just copied and pasted the problems right out of the online book assignment. And so I'm just going to show you how I would solve them. So first thing to notice here is if this all increases by adding 3. And I just usually check, is it always add 3? Yes, it's all the same. So then I check on the bottom, and when I look at this, I'm looking for how it increases from 0 to 3. It goes from 0.25 to 1, and from 1 to 4, and 4 to 6. So the first thing I notice is that's not a common rate. It's not adding or subtracting, so I would check to see is there a common ratio that I multiply by. And if I don't know that, I could take 1, divide it by 0.25, and I would get 4. So my common rate, or my common ratio, is multiplied by 4. And then I just have to check, are they all multiplied by 4? And in this instance, they are. So our common rate is multiplying by 4. Now because it's a common ratio, because we're multiplying, that's a times and a times, then that means this is an exponential function. So all exponential functions increase by multiplying by a common ratio. And the data have a common ratio would be the reasoning there. Number 2, we're going to look at this again, and we notice that these are all adding by 5. So I just check, yep, they're all adding by 5. And then this one looks a little different because it goes down and then it goes up. So I don't notice a common ratio. So I'm going to look for a common rate. So what I do is I say, how do I get from 4 to 3? Well, that's minus 1. And then to get from 3 to 7, that's plus 4. Now they're not looking like they're going to amount to anything, but just keep going because sometimes there's a pattern that you just don't see yet. So that's a plus 9, and this is a plus 14, and then it would be plus 19. And that's obviously not a common rate. So then we do the second differences. To get from negative 1 to positive 4, that's adding a 5. And to get from 4 to 9, that's also adding a 5. And from 9 to 14, that is also adding a 5. And 14 to 19, adding a 5. So this does have a common rate, but it's the second differences. If the first differences are the same, then it's linear. If the second differences are the same, then it's a quadratic function. So this one is quadratic function, and the reason is that the second differences are the same. Now number 3, we're going to start with the same thing. So to get from negative 3 to negative 1, we're adding 2. Check, is these all adding 2? Yep, they are. So now we can just focus on the y's. To get from 61 to 5, that is subtracting 56. To get from 5 to 5, that's not changing any, so I'm just going to put plus 0. To get from 5 to 13, that's adding 8. To get from 13 to negative 19, that's subtracting 32. And to get from negative 19 to negative 139, that's subtracting 120. First differences are obviously not the same, so let's check second differences. To get from negative 56 to 0, that's adding 56. From 0 to 8, that's adding 8. To get from 8 to negative 32, that is subtracting 40. And to get from negative 32 to negative 20, that's subtracting 88. Now, second differences aren't the same, so we check third differences. To get from 56 to 48, we would subtract 48. To get from positive 8 to negative 40, we subtract 48. And to get from negative 40 to negative 88, subtract 48. So look at that. Third differences are the same. So this represents a cubic function, or a power of 3 equation. And the reason, the differences are constant. Number 4, write an exponential function whose graph passes through the points 1, 3, and 2, 12. Now there's a way to do it, and this is how we used to do it in Math 1 and Math 2. And then there's the way using the natural log of y. I'm going to show you both. But if you can do the first way, I think it's a lot easier. I prefer it. So I don't really care how you do it. This is just kind of to me, it involves a little more thinking, but I like it. I like it better. So I'm going to make a table of graphs, and I want to always start, I want to have my zero term. And since my points include 1 and 2, I'm going to include those there too. And I just complete the table with the points that I know already. Now what I'm looking for is I'm looking for the zero term, because that's going to be the a value. And then I'm looking for the multiplier, what I'm multiplying these by, because I'm told it's exponential, and that will be the b value. Well, this one I look at, how do you get from 3 to 4 multiplying, and I know that if I multiply by a 4, 3 times 4 is 12. So then I'm going to work backwards, and 3 divided by 4 is going to be 3/4. So our zero term, or our initial value, is 3/4, because 3/4 times 4 is just equal to 3. So now I know the equation is y equals, and the a value is the initial value, or the zero term, 3/4, the multiplier is 4 to the x. Okay, now I'm going to show you the natural log of y way. And how we do this is we're first going to change the points to x, and then the natural log of y. So you grab a calculator, and the natural log of 3 is 1.0986. So I'm just going to round it to 1.1, and that will be close enough. And then the point 212, I'm going to change to the natural log of 12. Natural log of 12 is 2.5. If I round it, 2.5. Okay. Now, the next thing I do is I find the slope. And the slope of these 2 points is 2.5 minus 1.1. I do the difference of the y's over the difference of the x's. And I get 2.5 minus 1.1 is 1.4 divided by 1, so it's just 1.4. And then I put it in this equation. It says the natural log of y minus the y value, y1, is equal to the slope of x minus the x value, so x minus 1. So natural log of y, we don't know that yet. I'm going to use this point 1 and point 1.1, so that's minus 1.1 equals 1.4 times x minus 1, because the x value is 1. Distribute the 1.4, we get 1.4x plus, minus, back up, minus 1.4. Go ahead and add that 1.1 here. So add 1.1. Now we have the natural log of y is equal to 1.4x minus 0.3. So it's 0.3. Because the negative 1.4 plus 1.1. Now, to get rid of the natural log, I'm going to raise everything to the e power. And when I do this, this whole thing is raised to the e power. Or we could think of it like this. It's e minus an e. So then we have this y equals e to the 1.4x times e to the negative 0.3. Then we grab a calculator, and we can figure out what e to the negative 0.3 is. E to the negative 0.3 is 0.74. So that's going to be our value that goes into the front. So 0.74. And that's pretty close to 3/4, 0.75. You remember we rounded up in here, so that's why it's off just a little bit there. So that's going to be our A value, 0.74, and then we can figure out what e to the 1.4 is, and that is 4.055, or we round that to a 4 to the x power. So notice we got the same thing, 0.74, 4 to the x. This would really be 0.75, or close enough. Okay, so you decide which way you want to use. I am going to show you my favorite way. If you'd like, you can email me and I'll show you the other way too. But I'm just going to try to do this the way that is my favorite. Alright, so we're going to start by making a table. And this time, we only know the points 3 and 5, so I'm going to make my table go from 0 to 5. I know that a 3 is 1 and the 5 is 4. I know this is exponential, so I know that I'm multiplying by something. I'm just going to call it by x. So I'm multiplying by x, and then from 1 to 2 I multiply by the x. And you'll see why I'm doing this in just a second, because I don't know what that multiplier is. So I look at my numbers 1, and I know that I have to take 1 and multiply it by x, and multiply it by x again, and then I get 4. So x squared is 4, so my multiplier, when I take the square root of both sides there, it's either going to be -3 or +3. We're going to go, or 2, I'm going to go with the 2. So we're multiplying by a 2. So 1 times 2 is 2, 2 times 2 is 4, then working backwards, 1 divided by 2 is 1/2. 1/2 divided by 2 is 1/4, and 1/4 divided by 2 is 1/8. So our equation is the 0 term, or the initial value, is 1/8. The multiplier is 2 to the x, and there is our equation. Number 5, going to do the same thing. So we know the points 1 and 3. So I want to figure out what the 1 is. I'm going to put a placeholder in there for 2 because we're going to need to know that. We know that 1, 2, and 3, 15. So now I have to think, I've got to multiply 2 by some number x, and then multiply it by the x again to get 50. So 2x squared is equal to 50. If I divide both sides by 2, I get x squared equals 25, and x is 5. So 2 times 5 is 10, 10 times 5 is 50, 2 divided by 5, working backwards, is 2/5. So there's our equation. Y equals, the initial term was 2/5. Our multiplier is 5 to the x. And there's our equation for number 6. Number 7, going to do the same thing, only this time it goes from -1 to 4. So I'm going to start with -1. I want to find my 0 term, and then I'm going to go all the way down here to number 4. And -1 was 10, and 4 was 0.31. So I'm filling my table here. Okay, now I'm going to see, I'm multiplying by x. 1, 2, 3, 4, 5, and I know I'm going to start with 10. I multiply by x to the 5th, because that's multiplying by x 5 times, and I get this 0.31. That should be a 31 down there.